Okay, I'm going to get started. Usually there's a few that join tardy, but you can't usually predict that, so I wait. My name's Don Bowman, for those who haven't met. And today I'm going to talk about web application securities. Particularly, there's a set of well-known threats called the OWASP Top 10. And I'm going to talk about a specific strategy for defending against them. So defense in depth, I never believe in saying do A and it will 100% fix B. I think in terms of if you do A, it makes B much less likely to occur and it gives you more time to react. So what we're going to talk about today is adding a strategy of an identity-aware firewall as part of a protection mechanism against a set of web threats, which are fairly common. And so that's my agenda today, talk about those threats. Zero trust, there's a lot of material out there about zero trust. In a nutshell, it's the intersection set of identity with authorization and access, bringing that together so that everything is a single pairwise approach. So rather than, I log in and I VPN to a building and then I have access to everything, it's me and that resource pairwise, what am I allowed to do on it? We'll talk about how that can be a great strategy for web application vulnerabilities. And then how to get started. And I'll give you a live demonstration because, you can't have talk like this without a demo. So what do we do? Because this is obviously a little bit of an infotainment commercial. Agilicus is all about making, simple secure access. Any user should be able to access any application from any location, from any device. And we should be able to make security not a barrier, but actually an enabler. So zero trust is a way to do that. If you take identity and make it super simple to have a simple single sign-on experience that works across everything, users often say, I don't understand, I'm one person, why would I have more than one identity? I log into my bank with this mechanism, I log into Netflix with this mechanism, etc. Why can't I just have one strong spot, sign in with X and make it work? And then as an administrator, you often say, I'm prepared to accept those identity providers, but I need to control who can do what. And then you need to worry about then how to get them to that what. And this creates the troika, the 3 steps that you need to worry about. The who is that person? The what are they allowed to do? And the how do I get them there? If you solve who, what, how on a per person resource basis, you, my friend, have zero trust. And that's what it's all about. So the OWASP Top 10. What is OWASP? Well, OWASP is a foundation. It's a not-for-profit, and it's Open Web Application Security Project. And they've got a ton of great material on their website and many other websites, and many security researchers talk about it. So I'm not going to provide material additional value there today. But the key takeaway is they got a hit list. They keep track of which things have happened, which things have successfully broken through the barriers, and they rank them. And there's a top 10 list, and these are the top 10 most wanted mechanisms by which web applications become victim to criminals. And those are then categorized, and that category is coming up in a second. So first, we're going to talk about why zero trust. Zero trust, my proposal before I show you the list is these categories are fairly broad and they're in different places. Some relate to cryptography and some relate to JavaScript. And you can get lost in, each of those areas has a perfect solution that somebody's pitching to you for it. And I'm here to tell you that there is another layer you can put in which materially improves your security for not a lot of cost in addition to some of the other strategies. So coming back to that who, the what, the how, if every one of the web applications was only accessed by a person that you knew who was allowed to access it, you'd have a lot less concern about what they did on it, and that would provide great certainty. So if we look at these top 10 threats, I'm not going to go through a lot of slides today, so I'm going to spend a lot of time in this one, but this is the top 10 list. These are the things that cause almost all of the harm that's out there. And the first one's called broken access control. So believe it or not, the current kind of state of the art today that administrators, users, and application authors think about is every application does its own access control. So you log into Netflix, you log in as user, password, and then Netflix says, you have these rules. You log into your bank, you log into your corporate vacation planner. Every one of those applications was originally architected to have its own user and password system and its own set of access controls. Oh, you're an administrator, you can control the vacations. Oh, you're an end user, you can do this. Oh, you're a manager, you report on it. And believe it or not, when you move that problem domain out to the edge, some of those vendors, some of those authors, they get it wrong. And this is number one, is you got an application that thinks it's doing a good job, but you can change the URL and put $manager equals true and you sneak right by it. Number one threat. Number two is cryptographic failure or sensitive data. So in this regard, you've got one of a few things wrong. Either you've misconfigured your cryptography and you're using like an RC4 hash on your certificate or TLS1 or something, or you're storing unhashed passwords or some other sensitive data. And what happens is the attacker is able to exfiltrate that. Either your database gets leaked or your backups go to an offsite thing and they get leaked, or they just able to man in the middle your cryptography. This is your number two problem. It's a big problem out there. People think cryptography equals strong. Cryptography is only as strong as how you've set it up. The number three problem is injection. I talk on my YouTube channel a lot about this. Bridget will paste the link in there, but I go into great detail on something called content security policy. And there's a related one called CORS, or cross-origin request scripting. Content security policy, it's hard for people to get right. And the reason it's hard to get right is the web, people like to think, I go to this website and therefore all the content comes on that web server. Turns out that unless it's a trivial site, that's not true. It turns out that you go to that website and it uses what's called a CDN, and the CDN is a content hosting network, and you get a library called jQuery.js from there, and you get fonts from here, and you place ads on your site. There's an ad exchange that goes and bids it, and they get served from these networks, and you're using a library, and the library beacons back to its author to tell you how it's being used. Next thing you know, that web page you just opened thousands of web pages. And there's a site I use called Request Perf Mapping. You can type in your URL and you can see the tree of where you go. You are as strong as the weakest link in that tree. Every one of those things that you run, and it's called your DOM, but your domain, your origin, has full permission on your site. So you've got a web page that's got a form on it, and the user's entering some sensitive data, a username, a password, a Visa card, a SIN number, something like that. And you're using the CDN, and you're using an unpinned vulnerability version of jQuery, and it gets injected and it puts something else in there, and they exfiltrate your passwords in real time. They put a keylogger and they watch all the keystrokes on all the forms. They put an event listener on, and it's really hard to solve. But a content security policy is your main approach here. Is you assert positively, my site will only run active content of type script from A, it will only do this, B. And ideally, you can use something called sub-resource integrity, which hashes the content. I'll only run content I previously agreed upon. The fourth type is called insecure design. We're all human, and we make architectural decisions when we're implementing software, and sometimes they're imperfect, and they leak through, and they cause damage. The fifth is security misconfiguration. So you've got a software that's capable of being secure, but you've made a mistake, like you accidentally left the admin account enabled for single sign or sign on without multi-factor, or you allow the site to be accessed without cryptography. So you think it's encrypted and you test it that way, but people can just turn off HTTPS and they get back to it, and it's terrible. Number 6 is vulnerable or outdated components. We use internally a technology called Dependabot, and the Dependabot, hardest working member of my team. Dependabot works 24/7. Every day goes through all of they're called Git repos, but our software, and it looks for the dependencies that we have, and it looks to see if they've been, had improvements, and it then updates them and then runs our tests. And if they pass, it goes live. And it makes hundreds and hundreds of updates a week. A lot of commercial software out there doesn't have things like that, and they end up shipping it once and forgetting about it. And it just it's vulnerable, it's outdated, and it's not the main app, so you forget about it, but it's inside. Back to that injection problem, it doesn't have to inject, it is injected. Number 7 is identification authentication failures. Identity is hard. Okay, so the simple, humble username and password invented many, many years ago. It's hard to get that right, and companies either have these strategies of you got to change your password every 7 hours, and you can't recycle in the past 15, and it must have at least these character sets plus this, and it can't be pronounceable, and everybody writes it down. Or it's like, do whatever you like, and they make it their cat name with an exclamation mark. You take that problem, and then you turn around and realize that humans are human, and they will type that password to any screen that pops up, and then spear phishing comes in. And then you take another problem and say, well, actually, they've got multiple sites they use, so they type the password from site A into site B by accident, and now it has possession of it. And then, I accidentally typed my corporate password into my personal something account, and it's kind of a bad thing. It's very hard to do this right. Great software architecture allows identity to be a first-class citizen, and you use technologies like OpenID Connect or SAML to do it, and you have what's called single sign-on or enterprise sign-on or lots of different names, but you sign in with. I always counsel people, every time you as a personal user, you sign up to some new site, if it gives you the option to sign in with Google, do it. It is way more secure for you. It is more private for you. You're not giving up any information. There's no password to be breached. But people somehow feel the opposite. They're like, oh my God, I'm giving Google access to my something account. It's not how it works. The number 8 on the top 10 list is software data integrity failures. So it's similar to the insecure design, but here it's just a bug. All right. So somebody's made a mistake inside it, and it crashes, and while it crashes, it leaks some information or something of that nature. Or it allows you to, it's asking username, and instead of typing in Jane, you type in backtick, semicolon, drop tables, and next thing you know, you've got an XCD comic named after you for Little Bobby Tables, SQL injection. Number 9 is logging and monitoring failures. So what ends up happening is somebody's got a great application, and it's being probed. People are trying to get into it, and there's a common pattern they're using, and eventually they'll succeed. Defense in depth says you want to have the maximum amount of time for you to act. How do you act? Well, you've got to be able to monitor it. How do you monitor it? Well, you've got to settle logs. You see those failures occurring over and over again. A lot of applications get put live, and they just don't have any logging. They're like, after the fact, okay, it went bad. Where'd the data go? I don't know. We didn't log anything. Why didn't you log any data? I don't know. We forgot to turn it on. Misconfiguration. And the number 10 is not that common, but when it happens, you're dead. It's called server-side request forgery. In this model, I'm outside the web application in my browser. I convince your web backend, your server, to do something on the server for me. And we talk about that as lateral traversal. So usually when I come in through your least secure thing. Hey, I've got this community forum, and it's sort of anything goes, but it's hosted on the same database that my payroll's on, and I walk sideways through that. And now with the payroll information, I can reset the password of the administrators because I know all their details I would need, and boom, I own the whole organization. So these are the top 10 cyber threats in order of what they're causing. Now, back to the topic of today. It seems like there's a lot of different methods you would need to employ here, right? You would need to work with the developers to be more secure, and with your DevOps team to deploy more securely, etc. Today, I'm here to tell you about a singular approach which dramatically improves the security of all 10 of these. It does not fix everything. It is not a panacea. It's not a silver bullet. It's not like you say, do this and stop worrying. But between us, if you do what I'm about to say, your risk will go down dramatically. Your team will have more time to respond. You'll have less noisy things that are low-grade threats to deal with, and you'll be able to focus more of your valuable time on the real threats that are behind it in a defense in depth strategy. Defense in depth, it's like trench warfare. You got to have a place to fall back to, and you got to be able to control the speed of the enemy. What that is an identity-aware web application firewall. If I was to tell you this website, the only traffic that can arrive at it is for a user we've identified strongly, simply, and securely, and for a user that is allowed to do something on that website, and optionally for just the thing they're allowed to do, your risk envelope collapses. It doesn't go to zero, but it collapses. You're still worried a little bit of spear phishing and so on because those are still valid users, but you don't have to worry about people doing like an Nmap scan and finding you via Shodan and then using OpenVAS and finding a vulnerability and getting in because they're not a user. They're not valid. So if you put an identity-aware web application firewall, coincidentally, such as the one I make, in front of your web application, then on broken access controls, you can either view us as the only way to do access controls, which is kind of an API gateway model, or as a fallback position. Our system will guarantee the user that gets there is allowed to do something, and the thing they're trying to do is something that's in line with what their role is. We do that in the network on behalf of all the applications, rather than by updating a library here and there. You don't have to go visit them. You don't have to change the software on them. That category, the top category, is dramatically improved by just having those rule sets in the firewall and knowing who the user is and their role before you exit. The second is cryptography. Setting up SSL is surprisingly hard for a lot of folks. We work very hard on our team to make sure on the Open SSL labs we get an A+ on ours. TLS 1.3 only, strong cipher, elliptical ciphers only, no RSA, no RC4, no SHA-1. And keeping that up to date is a bit of a pain. By having the web application firewall in the path, now I know who the user is, and nobody can sort of inject in the side or get in the middle of that path. It's strong. The good thing is almost all the devices have come to a normalization point. It used to be we really had to worry about, Internet Explorer 11 was really what we're talking about here. That's the elephant in the room. And now that Internet Explorer 11, nothing supports it. Microsoft, nobody. Now we can move on with TLS 1.3 and so on, which is much better. The third is injection. So what did I say about injection? Content security policy is your number one solution here. You can look online, look on the Mozilla Developer Network, it talks about it. See the videos in my YouTube channel. There's a bunch that talk very specifically about web threats and so on. Our system, the web application firewall, can create the content security policy on behalf of your application and serve it if it doesn't itself. This instructs the user's browser what to do. The browser becomes a tool to help us. The browser is told, don't run any JavaScript from anywhere except these places. If something tries to inject itself, it gets blocked. Even if it's an extension in their browser, and this is an insidious threat, people get influenced to install extensions in their browser, and then they can sort of wander around the web page and do stuff. It gets caught by the content security policy because it tries to do something that the browser knows isn't allowed. So the web application firewall injects these rules for you and sort of helps fix that problem. Insecure design. This is a tough one. What does insecure design mean? It's a very broad statement. I have two things that they talk to each other over an unencrypted channel, or I have something internally, it doesn't check its parameters. There's only so much you can do from this externally. And we are talking about something here that is external. But by the same token, that insecure design is much harder to probe, poke, and infiltrate if the only traffic that arrives here is for a validated user, an authenticated user with a valid role. It means that the chances of them finding it, the chances of them exploiting it, there's a much smaller domain of people trying to attack you now. It's only your actual valid users, not the universe of humans. Security misconfiguration, the web application firewall can help you here as well. It's not perfect. If you're going to do something like leaving an administrative account open and unlocked, there's only so much you can do there. But the web application firewall, because only valid users get there, that account wouldn't work. If the misconfig is changing weak configuration on SSL, the web application firewall helps you because it overrides and it becomes your SSL proxy. So you can still get value in this layer here. The vulnerable outdated components. This is a really tough one to deal with externally. The main way we deal with that is by masking it. So somebody wants to come along and say, do you run jQuery version 1.2.3? I know the vulnerabilities in it and how to attack that. Turns out if you just lie to them, and I know your mom told you not to lie to people, but I'm lying to a bot on the internet, so I don't really feel too bad about it. And I say, we're running jQuery 4. And it goes, oh, well, I don't have any vulnerabilities, I'll move on. Or you say, no, I'm not running jQuery. I don't know what you're talking about. I don't have any of that here. The only users getting there are valid users doing valid things. Then I got to worry about a user who's been spear phished to click the link. And then I'm telling them that all the components are up to date. they're going to move on. And this is where I tell one of my favorite jokes. It's about two hikers and a bear. I got to tell this on every webinar because it's hilarious. You're out hiking with your friend suddenly bends over to tie their shoe. You're like, what are you doing? And then you see the bear. You're like, hey, you can't outrun a bear. And your friend says, I just have to outrun you. Attackers look for the low-hanging fruit. They look for the simplest thing to attack. If your site doesn't report any vulnerabilities, they move on to your neighbor. It's sad to be your neighbor, but it's okay to be you. That vulnerable, outdated component that we masked went away for them. From as far as they're concerned, it's not there, it's not a threat. Identification and authentication failures. It's hard to do this. We've done a great job of it. We use first-class identity providers. My strategy is anything that introduces a new username and password into your ecosystem is a mistake. I don't introduce one. We don't have any passwords in our system. It's not that they're stored in some beautiful hashed and encrypted model that I'm confident if it gets leaked, nothing bad will happen. I don't have one. You can leak all you want. I don't have it. I've never seen it. I don't know your password. I can't tell. We sign in with first-class identity providers, Google, Okta, Microsoft, the natural identity of your users. You might have more than one type of user, and they have their own natural identity. You might work with a vendor and a contractor and a bunch of students and co-ops, and some might sign in with their Google account, and some sign in with their Office 365 account and their whatever. When they're signing in with those, the password never goes to us. It solely goes to that upstream identity provider that has great abilities to interact safely and securely with that user. It helps you with spear phishing. The HTML always looks the same. All the login experience of all of your sites under us look identical. You don't have to worry about on site A, it's orange, and here, and site B, it's blue, and over here, it's always sign in with Microsoft. And your users get trained on that. It's much easier to say, if the sign in doesn't look like this, don't click it. That's what authentication failure is all about, is tricking those systems, tricking the users. Moving that into a layer in the network is just a great policy. Data integrity failures. This is also a tough one to deal with remotely. So, there's some JSON file or XML file that goes back and forth to the browser, and something happens and goes wrong in there, and et cetera. Dealing with that in the network comes back to the same thing. Only valid users get there. Doing only valid things is a strong thing. We have motion detecting lights in this room. 1 second. I got to work on that. So your layer here is only users that I know, doing things I know, makes the chance of a data integrity error go down, reduces the blast radius of where it goes when it happens. Security logging and monitoring failures. A web application firewall will have a single cryptographically proven audit trail of every action every user did forever. It's share. Shares are where ransomware spreads, right? We've all heard, oh my God, we got to get rid of the share because ransomware. You don't have to in our system. You can have your share and eat it too. I'll know who's done what on the share, what file has been accessed by who and when, and that log is immutable. And that way, if something happens, you'll be able to see, but also when something is happening, you'll be able to see. And now you don't have to worry about stitching together the logging systems of all these different websites and normalizing them, etc. You get a single throat to choke. The last one before we move on is server-side request forgery. Again, this is a tricky one because it's by definition very, very specific. It's somebody's found a way that your server is vulnerable to something. That being said, you can still improve it. Only known users, doing known things, get there is a strong, strong guarantee to help on number 10. These things are stacked ranked, and the Pareto effect, 80% of them are in the top 6 or 7. If you've materially improved your top 6 or 7 threats in this category, you're going to be materially better than your neighbor down the street. And back to the bear joke, you're not going to get eaten. So that's why I say there's a simple strategy to help improve generically the layer of security in web applications out there. It's an identity-aware web application firewall. Zero Trust is now doing that on a pairwise basis. So it's saying application 1 has these roles, has these users have those roles, therefore they can do this. Application 2 is separate. The users are signing into the applications independently. They're not VPNing into a network and then having access to all of them equally. There's no lateral traversal. I know I covered a lot of stuff. You're welcome to type questions into the chat. The video of this will be available afterwards in case you want to mock me for something. The strategy I'm I'm suggesting here is put a lot of effort into authentication. Figure out what your single sign-on strategy is. Use us or something else to enable multi-factor, even for older applications that don't support it. A share is a great example. Windows Share, we do multi-factor authentication on that. It's fairly unique. You want to have a share that, you know, you're doing a marketing launch, and there's an agency working with you on, there's some images in there, or there's an HR department, outsourced recruiting. That's a really good spot to, they're going to have their own authentication systems, but you're going to want to trust but verify, have the second factor on. But without allowing them to recycle their users and passwords. If every worker signs in with their personal identity, it means shared credentials vanish. An earlier webinar I did talked about shared credentials. We talked about how I trust company X, therefore there's an account for company X. What does that even mean? They've got 10 people today, yesterday it was 15, tomorrow it's 20. You know, they got people coming and going, but I'm not changing the password. Uh-oh, I have a problem. The shared credentials problem, when you have a supplier that has an account rather than a person. Accounts should have eyes. They should be a person. They shouldn't be roles. If you get that solved, and most companies now are in the position because they've all adopted G Suite or Office 365 or have adopted a great technology like Okta, they're all here now. They're ready to start reaping the rewards of that strong strategy. They just need to make sure that it works for their users and their partners and their temps and their building management people and HVAC contractors and so on. And the second, and you should outsource this. You should let authentication be done by that provider for you. Authorization, you need to own this. You cannot outsource this. You and you alone control who can do what. The what is authorization. Dawn, as attested by Google, is allowed to sign in and change the thermostat in the meeting room. That's authorization. You own that. You do not outsource that. That's what Zero Trust is about, is building that on a pairwise basis for each application. So just to really finish this section out, I'm going to give you a brief demo, but how the data flow goes. From an end user standpoint, there's no software to install. It works like everything else they've ever done, right? So that you're not having to retrain a workforce. They can use any device. They can pick up a tablet. They can pick up a, whatever, and they can sign in. The user is challenged to sign in via an identity provider that's called federated or unified identity. Then the second is there's an auditing event that occurs. Now I know who they are. I know where they're trying to go. We intersect where they're trying to go with what they're allowed to do. If there's at least one thing allowed and they're trying to do that thing, it continues on. And then the last part is getting to that thing. So here we have a concept called a connector. Everything is an outbound connection. We can work within networks that have no inbound IP. You're behind network address translation. You're behind a firewall. You're behind satellite. Everything is port 443 outbound and WebSocket in this model. This allows us to do stuff with industrial control systems, PLCs, thermostats, things of that nature that are fairly non-web centric. And that's sort of how it works. And I'm going to do a very brief demo. So brief that you might miss it if you're not paying attention or blinking. So first we will share the screen. And the first thing I'm going to show is it's called our profile. So this is an optional part. It's like a discovery vehicle, and it's kind of mobile optimized. It behaves as what's called a progressive web application. If it's installed on your phone, these are swipe trays. It looks like an application launcher. It looks like the native launcher of the phone. On the desktop, it's got the menu and looks a little different. But the idea is there's a set of applications they could request access to and say, hey, I'm on this team. I really should be allowed access. And then there's a set that you currently have. You can also see your shares. Shares can work web-based or mount natively on Windows, Linux, Mac. Here, I got a mysterious share called HR files, and I'm able to get it. This is on a NAS inside my house. The firewall doesn't allow me in, but I'm allowed to access files. If I read this juicy.txt file, there'll be a log created for that. You can do the same with remote desktops. I'm already signed into Profile, so I don't have to sign in. In a second, I'll show you the sign into the web application. But you can actually literally just open a desktop right here, and boom, it's right there in the browser, and you know that because the googly eyes move, that it's a live experience. We're bringing the desktop into the web, and you can set up your multi-factor. And then we have a concept called a launcher, which allows things that aren't web-based to participate as Windows desktop applications in the flow I'm about to show. But coming back to the OWASP top 10 and the web. Imagine that you are an organization that has a wiki or a pay stub system or forms for submitting claims or anything like that. Just imagine that you have it. And it's not being used by enough of your staff because it's hard to get to. You force them to VPN to the office, but you don't want the VPN in everybody's hands because some of the very itinerant workers, they're task-based, they only do one thing, or they're third parties and you don't want them VPNing there, so they don't have access to it. And maybe it's on the public internet, but it's kind of a weak username and password scheme, and you're thinking of putting IP-based blocks and how to get there. And you're worried that its login system isn't super strong because it's a username and a password, and you know those users are either writing it down or sharing it and using it across multiple things, and it's going to get in a breach someday. So here's what's going to happen. I'm going to launch the wiki. I could have not used the profile. I could have gone straight there with the original URL like we weren't involved, like the users have been trained on for a decade. But you're going to see immediately, I've just opened a new URL. It went to wiki.cloud.egov.city, the mythical city of egov. And immediately, because we don't know who the user is, I'm challenged to sign in. In my case, I can sign in with Apple, Google, or Microsoft credentials. This is themed for us. In your environment, this will be themed for you. This is where that federation comes in and allows you to say, we use Office 365, but we have this recruiting agency that uses Google G Suite. Both of us are allowed to sign into this application. So here I'm going to sign in with Google because we're a G Suite shop, and you're going to see me challenged for a second factor because I've turned second factor on for every single sign-on because the wiki is super important. But you're not going to see me type in a password into a URL that has our domain in it. So there we are. I currently have code-based or biometrics enabled. I'm going to make the biometrics work on my phone. 1 second, and you'll hear a beep. It beeped, and then I click on the thing, and I blink at it, and the radar maps my face and says, you're who you say you are, and the web application is now signed in, and I'm on the wiki. And this works whether I'm on a phone or a tablet, any device, any user, any network, any location, any time, and the user just uses the application as normal. Being signed into the wiki doesn't automatically sign them into this HMI application because there's no VPN. Each is individual. It's like each application is its own segregated island on the internet. Those OWASP top 10 are equally protected on all of these there. So that's basically the demo. Let's come back to the presentations. Next slide. So yeah, just to finish off, and you're welcome to type any questions in the chat, but we're basically wrapping up. Where do you get started? You know, it's easy to say, oh, wow, it's super complicated. That's a project we'll get a year's worth of, work on. It's not true. Most of the people that have implemented this have done it within an hour or so of getting started. We've got a bunch of customers in both Canada and the US that are doing municipal water treatment with us. We did a great project with our federal government on zero trust and industrial devices, and has been progressing well. People usually find that there's a low-hanging fruit. There's an application that's not getting enough use, and the main reason not getting enough use is people are worried about security, but they're not really doing anything about that, so it continues to rot. And you just want to get all the tools in the hands of all your staff at all the time, and think of that extended workforce. It's not just the 30 people that work directly for me and have signed an employment contract or in my Microsoft Active Directory, but it's the 300 people that are service providers for me, and they're equally important to my team in some way. They may just do a contracted HR or marketing for me, but I still need to get them into that share, that desktop. Maybe there's somebody who manages my physical plant, and they need access to the temperature control system. They need a remote desktop for that. So how do you get started? Pick an application or pick a user base. Recognize that you have that different classes of user that are out there. It's your constituents. They either work for you, or they're your customers, or they're your guests, or your contractors. Recognize they already have first-class identity systems of their own, just like you have. Recognizing they would prefer to sign in with that. Recognizing you can't outsource authorization. Recognizing those OWASP top 10 list of things do exist, but that a solution that the firewall blocks any traffic that isn't for an identified user doing an authorized thing is a super strong guarantee to get started. And that lowers your risk dramatically, which might allow you to expose that app to the world like it always wanted to be. So with that, I open the floor to questions. We will post this video online shortly, and an email will go out around on that for you. But thank you so much for attending today. It's always a little bit awkward at the end because I don't know if there are no questions and people don't know when to leave. So I won't be offended if you just leave, and I will certainly be thrilled if you ask a question in the chat. And certainly anyone from my team would be more than willing to follow up with you one-on-one afterwards if you're shy. You can email us info@agilicus.com or me, Don, at agilicus.com. Okay, so I will hang on here for about 2 minutes to see if there's no questions, but if you have none, feel free to drop. If you have one, you're welcome to start typing it now. Okay, with that, I'm going to assume there are no questions. Thank you so much for your time today, and enjoy OWASP Top 10 research and protection options. Cheers.